Okay, so here's a little video tutorial on how to do balancing equations. This might be something you're revising, or it might be something you've been taught and you're not quite sure how to do it or what it means. So here's an equation. At the moment it's not balanced. I can see that it's a formula equation, so it's understanding what these formulas actually mean, and we're going to talk about that. And the equation that I'm showing you here is a combustion equation because I've got my fuel. I'm reacting it with plenty of oxygen, so it's going to be complete combustion. And then the products, which are always to the right of the arrow, are water and my greenhouse gas, carbon dioxide. So first of all, what do we mean by it's not balanced? Well, the law of conservation of mass tells us that the atoms that go in can never be created, the atoms that come out can never be created or destroyed. So for example, if 2 carbons go in, I can't suddenly create an extra carbon and have 3 carbons on my product side. 2 carbons have gone in, I also can't just have 1 carbon on my product side because I can't destroy any atoms. So I can't create them and I can't destroy them. This is the reason why I haven't got any nitrogen on this side, because there's no nitrogen going in. So whichever atoms I have going in on my reactant side must come out on my product side, but they're going to be rearranged into new little molecules. So let's check to see what we mean by these formulas. So here's my fuel, C2H4. Have a think, how many carbons are in there and how many hydrogens are in there? What would that molecule look like? Now in an exam you won't have any little mollymods, but I do, so I can show them to you so you can get an idea of what that looks like. This here is ethene, it's the fuel, it's your C2H4. So this is what it looks like, my 2 carbons and my 4 hydrogens. Now I'm reacting this with an oxygen molecule. Have a think, how many oxygen atoms are in this molecule? You should have got 2, the little 2 means that I've got 2 oxygen atoms in that molecule. So I'm going to just place that there so you can see it. So these 2 are going to react together. If they've got enough energy going in, I can react these together to get my products. And my products, again, have a think, how many hydrogens, how many oxygens, and have a think, how many carbons and how many oxygens. And you can pause the video and see if you're right. So I'm going to start off with my water. So in my water, I've got 1 oxygen and I've got 2 hydrogens there. The white are my hydrogen. And my carbon dioxide, remember black was carbon, red is oxygen, and it looks like this. So that's my reaction. This is showing what I've got. And here, my reactant side and my product side. Now remember I said the law of conservation of mass says that whatever goes in must come out. And automatically I can see, well, I haven't got enough carbons, I haven't got enough oxygens, and I haven't got enough hydrogens on this side. I've got too many oxygens on this side, not nearly enough hydrogens, and not enough carbons. I know it's not balanced, and I need to balance it. But as I said, in an exam case, you're not going to have these mollymods to show it. So I'm going to show you how you would identify that now on a piece of paper. So in an exam situation, I like to do what's known as a shopping list. And I write down all the atoms that I've got to start with. So I know I've got carbon. I know I've got hydrogens, so they're my white atoms. And I know I also had red atoms, I had my oxygens. So I'm just getting that from all the letters I can see here for my elements that I've got. I don't have anything else in this equation. I then draw a line down from my shopping list and I count up how many I have on each side. So how many carbons do I have on this side? I've got 2. How many carbons do I have on this side? I've only got 1. Pause the video and see if you can do the same for the hydrogen and oxygen for both sides. Hydrogens, I've got 4 on this side. Hydrogens, I've only got 2 on that side. Oxygens, I've got 2 on this side. And oxygens, I've got 1, 2, 3 on this side. So this is if I haven't got mollymods in the exam, which you won't, you can simply do a little shopping list and you can see straight away what you need to balance. You can see it's unbalanced and what I need to balance. So I'm going to put this aside for now and I'm going to show you what do we mean by balancing. Well, first of all, one thing I can't do, so if I've got CO2 on this side, So if I've got CO2, I can't say, well, I haven't got enough carbon, so I'm just going to add another one there. Because now that's not carbon dioxide. That would be incorrect. That's a completely different compound that can't exist. So I must never ever change the formula. But what I can do, instead of changing the formula, I can say, well, I need another carbon, so why not have 2 lots of carbon dioxide? And I'll show you what that will look like. Now, just like in maths, science, we don't need to put the multiply there. We can just simply do this. That means I've got 2 lots of carbon dioxide. So let's see what that looks like. So we've already said, here's my fuel. We've said, here's my oxygen, here's my water, and here's my carbon dioxide. Now, I want to balance out my carbons, and so we said a way of doing that is just to put an extra carbon dioxide in. So now I've got 2 carbon dioxides. Let me just separate this so you can see which is your product side and which is your reactant side. So here are my products, here are my reactants. By adding another carbon dioxide in, now my carbons are balanced. I've got 2 here and I've got 2 here. Hopefully you've spotted a problem. You can see that I've now got far too many oxygens. 1, 2, 3, 4, 5 oxygens. I've only got 2 here. That's going to be a problem. So we're going to balance that in a minute. I can also see that I've only got 2 hydrogens here. I've got 4 here. Well, that's an easy one to do, because how many water molecules am I going to need in order to have the right number of hydrogens? Pause it and check. If I have 2 water molecules, I've now got 4 hydrogens on my reactant side, 4 hydrogens on my product side. My carbons are balanced, my hydrogen are balanced. I have got far too many oxygens here and not enough on this side. I need to have 1, 2, 3, 4, 5, 6 oxygen. I've only got 2 here. How about if I have another oxygen molecule? Is it balanced now? If I've got 2 lots of oxygen? No, it's not. I still need another one. So if I have 3 lots of oxygen, it's not wanting to sit there. Now I've got my 3 lots of oxygen. I can see I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It is balanced. So how would I do this in an exam? What would this look like? So for this, I've got 1 lot of ethene. I said I needed 3 lots of oxygen, so I put my 3 here to show I've got 3 lots of oxygen. I said I'm going to make 2 water molecules. My 2 goes there. And I'm going to make 2 lots of carbon dioxide. If I'm unsure, I can go back to my shopping list and see if I've got this right. I'll just get rid of this part here. It's not off-putting. I can have a look to see what I've got on each side. Carbons, I've got 2. What's my carbons like now on this side? I've got 2. How many hydrogens have I got on this side? I've got 4. How many hydrogens have I got on this side? Well, I had 2 lots of water. 2 times 2 is 4. How many oxygens have I got on this side? 3 lots of O2. That's going to be 6 oxygens on this side. How many oxygens have I got on this side? 2 times 2 is 4. Plus 2 is 6. So I can see that I am balanced. And that is how you balance an equation. So now you just got to practice.